This is video problem number 8. It's on specific heat. Let's see what we got. In a lab, you want to determine the specific heat capacity of an unknown metal. So we're looking for the specific heat capacity of the metal. The 212 gram piece of metal, so the mass of the metal is 212 grams, is initially placed in boiling water. So the temperature initial of the metal is 99.7 degrees Celsius and allowed to reach thermal equilibrium. In other words, that's the metal heats up to that. The metal is then placed into a coffee cup calorimeter that initially holds 50 grams of water, so the mass of the water is 50 grams. The specific heat capacity of the water is 4.184 joules per gram degree Celsius. And that's the initial temperature of the water, so the temperature initial of the water is 23 degrees Celsius. The metal and water have, it's embarrassing, a final temperature of 42.2 degrees Celsius. So the temperature final of the water is equal to 42.2 degrees Celsius. The temperature final of the metal is also 42.2 degrees Celsius. Determine the specific heat capacity of the metal, assuming no heat is lost to the environment. So what we're using here is the fact that whatever heat the metal gives off, that's how much heat the water is going to gain. Okay? So understanding that, we can then break this out to say the mass of the metal times the specific heat capacity of the metal times the delta T of the metal is equal to the mass of the water times the specific heat capacity of the water times the delta T of the water. And notice we are looking for this. So luckily we have an equation here that gives us what we need. So let's plug in some numbers. The mass of the metal is 212 grams. The specific heat capacity of the metal is what we're looking for. The delta T of the metal, that's temperature final minus temperature initial. The final temperature is down here, 42.2. minus the initial temperature, which is 99.7. Now, that whole thing should be negative, so we're going to put a negative out there. Now, that's equal to the mass of the water, which is 50 grams, times the specific heat capacity of the water, which is 4.184. That's joules per gram degree Celsius. Times the delta T of the water, which is going to be the final temperature of the water, which is 42.2, minus the initial temperature of the water, which is 23. So, I don't know, I can work through this, I guess. Take your time, do it stepwise. So this ends up being negative 57.5. times specific heat capacity of the metal, which is what I'm looking for, times 212, and that whole thing is negative. Let's see what I get over here. I've got 50 times 4.184 times parentheses 42.2 minus 23 in parentheses, and so on this side I get 4,016.64. Now that's the amount of heat that the metal or that the water absorbed. That's why it's positive. So let's see what we get over here. We've got 212 times negative 57.5. So I've got negative 12,190. That's times the specific heat capacity of the metal. And so I'm just going to divide both sides by 12,190. So I got that value divided by that value. So I end up with a specific heat capacity of the metal equal to 0.330 joules per gram degree Celsius.